Confused between positive and negative inductive effects? Don't worry. By the end of this video, you will not only understand inductive effect, but also be able to recognize whether a group shows positive or negative inductive effect. Stay with me till the end of this video because at the end I'm going to give you a simple trick by which you can easily recognize the positive and negative inductive effects. Hi, I am Dr. Swathi, Organic Chemistry Coach. If you have not subscribed my channel yet, hit subscribe button and keep notifications on so that you will never miss my next coming chemistry concepts and study hacks. Now let's jump into the topic. What is inductive effect? There will be flow of electrons from one side of the molecule to the other side due to the electronegativity differences between the bonded atoms. This creates regions of high electron density and low electron density in a molecule. So wherever low electron density is there, that causes generation of partial positive charge, and wherever high electron density is there, those atoms or groups will be attaining partial negative charge. So this type of effect is known as inductive effect, and it is one of the permanent effect. Inductive effect is mainly caused due to the presence of electron releasing or withdrawing groups and transmitted through sigma bonds in a molecule. This effect is more prominent over a short distance. Inductive effect decreases as the distance increases. That means it is distance dependent. There are two types of inductive effects are there: negative inductive effect and positive inductive effect. Now let me discuss about these two with examples. Negative inductive effect occurs when an atom or group withdraws electrons from the rest of the molecule. This effect is seen whenever a molecule is having electron withdrawing groups, such as halogens, fluorine, chlorine, bromine, iodine, nitro, cyano, and carboxylic groups. These are all the examples for electron withdrawing groups. Whenever such type of electron withdrawing groups are present, these groups withdraw electrons from the rest of the molecule, and thus partial positive charge will be created on the carbon atom which is just adjacent to the electron withdrawing group. Now, in order to compensate the partial positive charge on the carbon atom, the bonded pair of electrons from the adjacent position will be moved towards the partially positively charged carbon. Because of that reason, the second carbon will be attaining partial positive charge, which is denoted with double delta plus. So the partial positive charge which is generated on the second carbon is less when compared with the positive charge generated on the first carbon. And the same phenomena continues throughout the carbon chain. But this negative inductive effect will be more prominent on the carbon atom which is just adjacent to the electron withdrawing group. As the distance between the carbon and the electron withdrawing group increases, the inductive effect decreases. The second type is positive inductive effect. This occurs when an atom or group donates electron density to the rest of the molecule. Whenever a molecule is having electron donating or releasing groups, such as alkyl groups, for example, methyl, ethyl, propyl, or groups like carboxylate, that is COO minus groups, and also amino groups. So these are the examples for electron releasing groups. So whenever electron releasing groups are present in the molecule, they will release the electrons or donate the electrons to the rest of the molecule. So the carbon which is adjacent to these groups, because of the donation of electrons, attains partial negative charge. Now to compensate the partial negative charge on that carbon, the neighboring bonded pair of electrons will be attracted by the next carbon. And that is how the next carbon also attains partial negative charge, which is denoted with double delta minus. But this double delta minus will be having less negativity when compared with the delta minus. So here also the inductive effect decreases as the distance from the electron donating group increases. Importance of inductive effect. This inductive effect explains the acid strength. That is why chloroacetic acid is stronger than acetic acid. And also it explains the stability of carbocations. That is, tertiary carbocations are more stable than secondary, which in turn more stable than primary. So these phenomena can be better explained with the help of inductive effect. Let me explain these two applications briefly. The first one is inductive effect is useful to explain the acid strengths. That is why chloroacetic acid is stronger when compared with acetic acid. So these are the structures of chloroacetic acid and acetic acid. So the ability to lose proton is considered to be acid strength. That means the acid which loses proton easily, that means which undergoes deprotonation easily, is considered to be stronger in terms of acidic strength when compared with the other. So upon deprotonation, these carboxylic acids will be giving corresponding carboxylate ion. So the acidic strength, it depends on the stability of the resulting carboxylate ion. So in case of chloroacetic acid, the resulting carboxylate ion structure, if you see here, chlorine being electronegative group, it withdraws the electrons from the carbon. Thus, there will be generation of partial positive charge on the alpha carbon. And this carbon is already neighboring to a carboxylate carbon, which is highly electronegative in nature. So what happens here is, due to the generation of positive charge on the alpha carbon, it will try to take up the electron cloud from the carboxylate carbon. Thus, there will be dispersal of the negative charge. The negative charge is not concentrated on the carboxylate carbon. Instead, it is distributed throughout the molecule. So, this dispersal of negative charge causes stabilization of the resulting ion. Thus, the resulting carboxylate ion in case of chloroacetic acid is stable due to the presence of electron withdrawing chlorine. So, this is the structure of the resulting carboxylate ion in case of acetic acid. So here this carboxylate carbon is adjacent to methyl group. Methyl group is an example for plus I group, that is positive inductive effect showing group, because it is electron releasing in nature. So it releases the electrons or donates the electrons towards the carboxylate carbon. And this carboxylate carbon is already having electronegativity. Okay, so this is the reason this causes intensification of negative charge on the ion. So whenever there is intensification of negative charge, the resulting molecule or ion acts more or less like an anion. And you know that anions are highly unstable in nature. So immediately they will try to undergo some reaction to attain the stability. That means the resulting carboxylate ion in case of acetic acid, due to the presence of electron donating methyl group, is highly unstable. Out of the two carboxylate ions formed, carboxylate ion which is formed from chloroacetic acid is more stable than the acetic acid carboxylate ion. So greater the stability of the resulting carboxylate ion, greater will be the chances for the deprotonation, and more easily the deprotonation occurs. And that is how chloroacetic acid is stronger in terms of acidic property when compared with acetic acid. So the acid strength can be explained with the help of inductive effect. Now, the second application is carbocation stability. So, for that, let us consider carbocation structure. So, this is primary carbocation, where the positive charge is present on a primary carbon, because this carbon is attached to one more carbon. That's why it is primary carbon. So, when positive charge is present on a primary carbon, that is known as primary carbocation. Now, let us consider an example for secondary carbocation. So, in this structure, the positive charge is present on a secondary carbon, because this carbon is attached to two more carbon atoms. So when a positive charge is present on a secondary carbon, that is known as a secondary carbocation. Now coming to the tertiary carbocation, this is an example. So here the positive charge is present on a tertiary carbon, because this in turn is attached to three more carbons. So in case of primary carbocation, the carbon which is bearing the positive charge is adjacent to one methyl group. As I mentioned earlier, methyl group is an example for plus I effect showing group. That means it releases electrons towards the remaining chain. So it donates electrons to the carbon which is bearing the positive charge. That is how causes stabilization of the ion. Now, in case of secondary carbocation, the carbon which is bearing the positive charge is adjacent to two electron releasing methyl groups. Okay, so from two sides here, there will be donation of electrons towards the carbon bearing the positive charge. So here the positive charge in case of secondary carbocation will be more readily stabilized when compared with primary, because primary is having only one electron releasing group. Now coming to the tertiary carbocation, carbon bearing the positive charge is attached to three electron releasing methyl groups. That means from three sides there will be electrons donation towards the carbon bearing the positive charge. So here the positive charge will be more readily neutralized due to the presence of more number of electron releasing groups. So greater the number of electron releasing groups in a molecule, greater the stabilization of the resulting ion. Hence, it forms a stable carbocation. And due to the presence of 3 electron donating methyl groups in tertiary carbocation structure, this tertiary carbocation is more stable when compared with secondary and primary. That is the reason the stability order for carbocations is tertiary is more stable than secondary than primary. So greater the stability of the carbocation, more easily or fastly it will be formed in a reaction. Hence, the ease of formation of carbocation follows the same order. Tertiary carbocations are more easily formed than secondary and primary carbocations. So this is how the stability of carbocations can be explained with the help of inductive effect. So as I promised earlier, here is a quick simple trick to recognize the plus I and minus I groups instantly. Whenever electronegative groups or electron withdrawing groups are present, that means that is negative inductive effect. And whenever electron releasing or donating groups are present, like methyl, amino group, or any alkyl groups, such type of groups are the examples for electron donating groups. So whenever electron donating or releasing groups are present, they will show positive inductive effect. Okay, so this is how you can remember. Electron withdrawing, electronegative is nothing but electron withdrawing. Negative means minus I. Okay, and electron releasing or donating, it gives, that means plus. Okay, so that is plus I effect. So this is how simply you can remember plus I and minus I groups. Now let me quickly revise this particular topic. This inductive effect mainly arises due to electronegativity differences in the molecule, and it is a permanent effect. And there are 2 types of inductive effects are there. Negative inductive effect will be observed whenever electron withdrawing groups are present in a molecule. And the second one is positive inductive effect, which occurs due to the presence of electron donating groups. And this inductive effect will be distance dependent. That means this effect is more prominent on the neighboring carbon. When the distance increases, the inductive effect decreases. If this video made inductive effect crystal clear for you, then hit the like button and share it with your friends. Subscribe my channel for more chemistry concepts and quick hacks. So this inductive effect is one of the core topic in organic chemistry. Similar to inductive effect, if you want to learn about any core topics, I have already made a detailed video on covalent bonds, which is available in my YouTube channel. And I have given the link of that video in the description. And here is a quick challenge for you. Comment below one example each for positive I and negative I groups from your syllabus. Thanks for watching and stay tuned to my next videos.